All right, guys, we're going to talk up today. We're going to finish up 4.1. This is 4.1 part 2. We're going to talk today about linear speed, arc length. All right, we're going to find out how to calculate those things. To figure out the measure of a radian, if you're given a circle and you're trying to figure out what the central angle is, the radian in the middle. Okay, this is our theta. Everybody familiar with this Greek symbol? This is theta. This is pronounced theta. But the formula for that is to take S, which is your arc length, and divide it by your radius. Okay? So if I were to rearrange those letters, I have my arc length formula. S equals R times theta. S is your arc length. R is your radius. And theta is the central angle that intercepts the arc. I'll show you what I mean by that in a second. When we talk about this, guys, you're talking about what kind of measurement? Radian. A lot of times, they'll give you a question. It'll say, determine the arc length. And they'll tell you that theta, the central angle, is in a degree measurement. What do we have to do first before we can calculate arc length? What do we have to make sure theta is always in? You've got to make sure it's in radians. Has to be in radians. If you are given a central angle in degrees, which a lot of times you are, you must convert it to radians first. The math behind this is super simple, but if you don't do that, you're going to get the answer wrong. So if I look at a question like this, all right, circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle. Okay, what they're saying is they're telling you that 240 is the central angle right here. The arc that intercepts it, it's the one that's like right across from the central angle. They want to know how big that is. So here is your picture. You don't always have to have a picture. They can just tell you this information in words. Now, you guys will not have a calculator on Friday with your quiz. 4142, no calculators. You have to do all this by hand. You're going to be told to leave things in terms of pi. That means just pi will be in your answer. You won't have to times it by 3.14. But if you're going to find the arc length here, guys, S equals R times theta. Agreed? Did they give me my R? What is my radius? 4, okay. Did they give me theta? Yes, what is my theta? 240 degrees. Now, on your quiz, you guys, some of you are going to multiply 240 times 4 and tell me what the arc length is. Is that the correct way to do this problem? What do we have to do with 240? You've got to convert it to degrees, from degrees to radians. How would I do that? What's our conversion? If I start off in degrees, where does pi go? Where does 180 go? Multiply by pi over 180. 180 is going to go in the denominator. Why is 180 going to go in the denominator? Because we want our degrees to do what? Cancel out. So look, your zeros and your degrees cancel. What number goes into both 24 and 18? 6, okay? 6 goes into 24 4 times. 6 goes into 18 3 times. So what is your theta in radians, guys? 4 pi over 3. Perfect. Now, can you figure out the arc length really simply? Yes. You would take your radius, which is 4, times it by your theta, which is 4 pi over 3. Again, if you need to put a 1 underneath, no problem. So if you're going to multiply fractions, how do you multiply? Straight across? What's 4 times 4? So I have 16 pi over 3. So my arc length, the length of my arc is 16 pi over 3, and we're measuring in what? Inches. This is leaving your answer in terms of pi. When it says leave your answer in terms of pi, that means you should have a pi symbol in your answer. Does that make sense? If they asked you to the nearest decimal, obviously you'd have to have a calculator, and you would use the pi button in your calculator. You'd hit 16 times pi divided by 3. Right? Does that make sense? Okay. Moving along. We're not going to talk about angular speed right now. We're going to talk about linear speed. If you notice, here is the linear speed formula. It's arc length divided by time. Well, what is arc length? Radius times theta over time. What do you think is really important to remember our theta has to be? in radians, okay? So you need to have your radius, you need to have a central angle in radians, and you need to have time. All right, linear speed measures how fast the particle moves. How quickly something moves, all right? Linear speed, like the speed of your car or something like that. A lot of times your linear speed is going to be asked in reference to a clock, all right? For calculation purposes, because we don't have calculators right now, I'm going to change this to just 10 centimeters, not 10.2. When you guys have a calculator on your test, I'll put decimals in. But since we don't have, just for easy calculation. It says the second hand of a clock is 10 centimeters long. Find the linear speed at the tip of the second hand. Well, think about your linear speed formula. Linear speed is radius times theta divided by time. What information did they give me by telling me that the second hand of the clock is 10 centimeters? The radius. All right, they're telling you that R is 10 centimeters. From the center to the outside here is 10 centimeters. That's what they're telling you with the clock. A lot of times we have clock problems like this. Now they're going to ask you, how fast is this thing moving? Dependent upon how far it's moving, okay? So this question, one question, could be asked 4 different ways. And I drew these pictures here. Either take a picture of this or whatever you guys need to do. Screenshot it, try and draw. But we're going to talk about a whole circle. We're going to talk about a whole circle in terms of central angle and in terms of time. So I'll give you a second to write these down or whatever you need to do. All right, so look at your circles. All right, we're going to look at each one independently. But how many pieces is your circle broken up into here? 4 pieces. How many pieces is a coordinate plane broken up into? 4. Right? Would you guys agree with me that on a coordinate plane, we start over here on the right-hand side. This is 0, correct? What's another way I could say that? That's 0 or what? How many degrees? 360. But we're not talking in degrees, are we? We're talking in radians. So 360 degrees is the same as 2 pi. Okay, good. So if I were to go around my circle, what's up here at 90 degrees? What is the radian measure at 90 degrees? Pi over 2, great. If I come over here at 180, it's just pi, good. If I come down here at 270, what is it? 3 pi over 2. And one whole circle, would you guys agree with me, is 2 pi, right? Okay. So now let's think in terms of time. How many seconds are in one whole circle? 60, okay? So if I broke this up into 4 pieces, how many seconds are in the first quarter? 15. How many are from 0 to pi? 30. How many are in 0 to 3 pi over 2? And then how many is in one whole circle? So when they tell you that you have a certain radius or your second hand is this long or whatever, when they tell you the revolution that they want you to use as your measurement, they're telling you the central angle and they're telling you the time that you can use. Think about it. If I go here, if I tell you a quarter revolution, 1 quarter revolution, that is right here. What is my central angle in this case? How far did I go? I went 90 degrees. What is that in radians? Pi over 2. And how many seconds elapsed when I went in this first quarter? 15 seconds. So your time is 15 seconds. You guys see that? All right, so let's talk about the second one. If I talk about a half revolution, half would be starting here at 0, and I go that much. What is my central angle? What's my theta? Pi, good. And how many seconds elapse in half of a circle? 30, very good. All right, I'm starting here at 0, and I talk about a 3/4 revolution. That's coming here and going all the way here. What's my central angle? 3 pi over 2. Perfect. And what is the time that elapsed? 45. And then if I talk about one whole circle, guys. I come here and I go all the way around. One full circle. So we'll say one full. What's my theta? 2 pi. And what's the time that elapsed? 60 seconds. So what you'll see is you'll have a question like the one above, right? They said that there was the radius, or your second hand was 10 centimeters, right? Well, what's the linear speed at a half revolution versus a full revolution versus a 3/4 revolution versus a quarter revolution? Does the radius, does the length of your second hand change? Yes or no? No. What's going to change? The time, and what else? The theta. If you're talking about linear speed is radius times theta, arc length over time. So in this first example, a half revolution, what is your theta? What is your measurement of your central angle in a half revolution? Pi, good. And what is the time? How much time elapsed in half of a circle? 30. So you would work this problem out. You say my radius is 10 over 1 times my theta is pi over 1, right? Divided by 30. Simplify the numerator first. What's 10 times pi? 10 pi over 30. What does that give you? Pi over 3. So it's pi over 3 centimeters per second. That's linear speed for half of a revolution. Well, let's use that same second hand, but let's go an entire revolution, the whole way around the clock. Well, in this case, my linear speed is still the same formula. What is my radius? It didn't change. It's still 10 over 1. But in this case, for a full revolution, what is your theta? 2 pi. And then what does your time become? 60. So you have 2 pi over 1 divided by 60. Well, simplify the numerator. What's 10 times 2 pi? 20 pi divided by 60 becomes what? Pi over 3 centimeters per second. You guys see that? All right, what about if I same radius, still radius of 10, but this time I'm telling you, well, what's the linear speed for a quarter revolution? What's your theta for a quarter revolution? For a quarter? Just pi over 2, good. And how much time elapses? 15. So let's set this up. It's radius times your theta in radians divided by your time. So 10 pi over 2 becomes what? 10 pi over 2 simplifies to pi over 5, right? Or 5 pi, I'm sorry, over 15. And then what? Oh, pi over 3 again. All right, let's do the same problem, but 3/4 revolution. My radius is still 10. I didn't change that from the beginning. But what is my 3/4 revolution? What is the theta that I'm talking about? 3 pi over 2. And what is the time that elapses in 3 pi over 2? 3/4 of a minute. 45 seconds. So this would become 10 over 1 times 3 pi over 2 divided by 45. Simplify the numerator first, guys. 10 times 3 is 30. So you have 30 pi over 2, which simplifies to 15 pi over 45 becomes what? Pi over 3 centimeters per second. What do you guys notice about all of your answers? They're all the same. Why is that? Why are they all the same? Okay, same radius. Good. I like your thinking. What are we talking about? second hand of a clock, right? Now, I know, first of all, you guys don't, some of you don't even know how to read a normal clock like that. But, and I know that sometimes, like in this class, it seems like the second hand goes really slow, right? And in lunch, it goes like really fast. Seems that way. But if you think about a clock, does your second hand speed up and slow down as it rotates around? Your linear speed is what? It's the same. It's constant. So I can give you a problem. I could give 4 of you the same radius and tell Ava, you have a half revolution. Connor, you have a full one. Cassie, you have a quarter. And Dylan, you have 3/4. Right? Your math, the numbers that you plug in are going to be different, but what should all 4 of your answers be? The same. So when they give you the radius of, or the second hand of a clock or something like that, they're telling you the radius, and then whatever the revolution is, they are telling you what the central angle is and what the time is, just by telling you how much of the circle your second hand has gone around. Does that make sense? Okay, all right.